Okay, so I was saying we have this the generating function for the Legendre polynomials. As you have seen in your previous case when we were discussing about the Bessel function. So we had the generating function for the Bessel function, that we had some function from which we can generate those Bessel functions, a particular function, and we call that function as a generating function. Similarly, for the Legendre polynomials, as we discussed it yesterday, some Legendre polynomials of first kind as well as the second kind. Now we will see whether we can have any function where we can generate these Legendre polynomials from that very function, right? Now, the origin, as I said in the very first class, that the Legendre polynomials actually, or the Legendre differential actually appears in when we separate out your Helmholtz or the Laplace equation in the spherical coordinates, and it exists for the central force problems. So here, the origin of this Legendre polynomial is actually lies in the treatment of the potential problems. The origin of this Legendre polynomial treatment of potential problems. So what I mean by the potential problems, for example, I need to find out the potential at a point R due to some point charge Q dash. Like for example, if I have this, I need to find out the potential at this point P due to some another point charge Q dash, right? So let me draw it like this. If they are in the frame of reference like this, okay. So I need to find out the potential at a point P due to this charge Q dash. So the such that this Q dash is the distance R dash away from this point, and the potential, this is from the center, this is R. Okay, now what could be this? You know that this will be R minus R dash, right? Okay, so we need to find out the potential at the point R at point P, which is at a distance apart from the origin, due to this source charge, due to this point charge Q dash that is located at R dash, right? Now, how is the potential given by? You know that the potential, if I represent it by phi of R, it's given by some 1 by 4 pi epsilon naught Q dash divided by some R minus R dash from the Coulomb's potential, right? This is what I mean by the Coulomb potential. See, I can write down this equation as, I will write down this as 1 by 4 pi epsilon naught, okay? Or I will just say that Q dash divided by 4 pi epsilon naught. Now see, I will write down this as 1 divided by R square plus minus 2R dot R dash plus R plus R dash square is to power 1 over 2. Because see, I can write down this as R minus R dash square whole square, right? Now this and this will cancel out, and we get R minus R dash. So I will just, so then what I did, I just expand it. This is R square, A square plus B square minus twice R into R dash plus R dash square. Okay, so that's what I did here. Okay, now why I did it? I did it for a reason. Now what I will use, since you know that the dot product of the two vectors R dot R dash is always given by uh, R dash cos of theta. So now I will assume here the cos of theta is equal to x, and R is equal to R dash is equal to h, right? So what will this equation now become? So this will become Q dash divided by 4 pi epsilon naught, okay, 1 divided by, okay. Now this, sorry, R dash by R is equal to h. So this will be equal to 1 minus, this will be x, because R dot R dash, this is R dot R. So this will be minus twice xh, twice xh plus this is R dash square is h square, right? 1 minus 2x raised to power 1 by 2. Is it okay? Or I can write down this as Q dash divided by 4 pi epsilon naught. This is some constant. I will write down this as 1 minus 2xh plus h square raised to power. This is not true here. R dash by r is equal to h. Okay, so what I will do then, I will just divide throughout by r. When I divide throughout by r square rather, so this will be 1 minus r dash by r will be equal to h. R dash by r is equal to h, right? So यहाँ पे आपका क्या हो जाएगा? This will be, I will just come to it in a while. Okay, so raised power minus 1 by 2. ठीक है? So this is an expression. This is a potential phi of r. Is it okay or I need to elaborate it? I just divide throughout by r square, so it will be 1 minus 2 r dash by r, right? R dash by r, one r will get cancelled out, and okay, so r square by r square by r dash square is h square. Is it okay or not? Okay, now so what we will do, we will just express the potential in the powers of h. So this potential is often actually expressed in the powers of h for a given values of x, for a given values of x. So this function, this is a constant, this term is a constant. So this constant, the potential is given by, the potential is expressed as a powers of h. So I will represent it by the gxh will be equal to 1 minus this 2xh plus h square raised to power minus 1 by 2. Okay. So this is what we call as a generated function. And when we will expand it by the binomial expansion, this will give me the summation over some m running from 0 to infinity pmx h raised to power m. I will show you this in a while. कैसे ये बड़ा, how we can have the Legendre polynomials from this expansion. So this is actually, this is what we call as a generating function. So this particular function is a generating function, and we can generate the Legendre polynomials from this very equation, right? Okay. Now the expansion coefficients, this जो expansion coefficients यहाँ पे मिलेंगे from this because we will have a p0x p1 xh p2 xh, ये आपका जो होगा when summation m is equal to 0, it will be p0 of x. When m is equal to 1, it will be plus h p1 of x plus h square p2 of x plus h cube p3 of x plus so on. So these are the actually the, and we will have the expansion in h on the left hand side. ठीक है? So the expansion coefficients here, the expansion coefficients, the coefficients which we will get from the expansion of this, those coefficients are called pmx because we are expanding it as a powers of h. So the coefficient, the expansion coefficient pmx are actually a set of polynomials, or a set of polynomials of order m. Polynomial I mean the Legendre polynomial. ठीक है? And this gx of h is known as generating function. This is known as generating function for Legendre polynomial. Okay, so do you understand what, where does actually the origin of this Legendre polynomial is? So we actually try to derive it from the center force problem, which is called as a potential problem, where we need to find out the potential at a point due to some point charge. And we can say that when we will expand this particular expansion, we will have a Legendre polynomials. We will have a Legendre expansion of the Legendre polynomials. So now let me show you how we can obtain these the Legendre polynomials, because the Legendre polynomials you already know what are actually they look like. So in order to do that, what I will do, so see, I will write down this generating function 1 minus 2xh plus h square raised to power minus 1 by 2. Can I write it like 1 minus 2x h into 2x minus h, right, raised to power minus 1 by 2, isn't it? This is 2xh minus h square plus h square. Okay, so this is one and the same. Now see, you know that the binomial expansion आपको पता है क्या है? 1 plus x raised to power n किसके बराबर होता है? It is always equal to 1 raised to power n, that is 1 plus n into b n x plus n into n minus 1 divided by 2 factorial x raised to power 2 plus n into n minus 1 into n minus 2 divided by 3 factorial x raised to power 3 plus so on. This is what we call as binomial. So that I'm going to use, I have n here is 2 and I can have the binomial expansion for this particular. So how I will write 1 raised to power minus 1 by 2, that is simply 1 a plus, now this is minus into minus will become plus. So it will be 1 by 2 into h. So I will write down this as h by 2 into 2x minus h, right? First term, and x plus, okay. So now it will be minus 1 by 2, minus is already there. It will be 1 by 2 into 1 by 2 minus 1, that is 3 by 2, sorry, 3 by 4, then h square, x square, because this term whole square. It will be h square into 2x minus h whole square from this very formula plus, okay, then we have the another term, okay, so plus so on some other terms. Now I will write down some general terms, because third term, fourth term, what could be the third term, by the way, it will be 1 by 2, 3 by 4 minus 5 by 8 h cube 2x minus h raised to power 3. So we will have the another term like plus 1 by 2, 3 by 4, so on. This is 2m minus 3 divided by 2m minus 2, 2m minus 2, then h raised to power m minus 1, 2x minus h raised to power m minus 1 plus the next term will be 1, 3, so on, then 2m minus 1 divided by इसके बाद वाली जो term होगी, this is last but one term, 2.4, so on up to 2m, okay, h raised to power n, m 2x minus h raised to power m plus some infinite terms also we have, but this is this term, okay. Now see, try to understand here. Now we need to find out the coefficient of h raised to power m from these terms. Now the coefficient of h raised to power m, how we can find out that? And I will start with this term, the coefficient of h raised to power in this term. What could be the coefficient of h raised to power in this term? I will just expand this again by the binomial expansion. So it will be now, so the coefficients of this h raised to power m. I will take one by one. Take this term first. So it will be coefficient of h raised to power m. यहाँ पे क्या होगा? It will be 1, 3, so on, 2m minus 1 divided by 2, 4, so on, 2m. Okay. Now h raised to power m coefficient. So it will be 2x minus h raised to power m. So it will be 2, the coefficient here will be 2x raised to power m. इसको आप जरा खोल के देख लीजिएगा खुद से रफ पे करके. So the coefficient will be 2x raised to power m now. Okay, plus the next term, इसके बाद वाली term, ये वाली term, it will be now 1 into 3. So this is what I am doing from this very formula, binomial expansion. 1, 3, so on, 2m minus 3 divided by 2, 4, so on, 2m minus 2. Okay, so what could be this the coefficient now? The coefficient will be now, because this is m minus 1 term, we have to find out the coefficient of m plus 1. So it will be the second term now. The second term will be now m minus 1, because we have this m minus 1 into 2x raised power, because the 2x term will be the m minus 2, right? Okay. Similarly we will have the another term. इसके पहले वाली term जो होगी, that will be 1, 3, so on, 2m minus 1, sorry, 2m minus 5 divided by 2, 4, so on, 2m minus 2m minus 4, 2m minus 2, 2m minus 4, इससे पहले वाली term. Okay, then what will be the next term then? Because इससे पहले वाली term, it will be now m minus 2, m minus 1, m minus 2, then 2x raised to power m minus 4. Plus I will have the another term. What will be the by the another term? Another term will be 1, 3, so on, 2m minus 7, 2, 4, 2m minus 6, m minus 3, 2x raised to power m minus 6. Are you getting my point or not? So these are just the coefficients of h raised to power m from this expansion जो हमने यहाँ पे किया है. Now see, I will just combine all these expansions as I can take some of the terms here common. So when taking the terms common, I will write down this as 1, 3, so on, 2m minus 1 divided by 2, 4, 6, so on, then 2m. Okay, and again 2 raised power m is throughout, 2 raised power m, 2 raised power m, 2 raised power m, 2 raised power m is here, यहाँ पे 2 raised power m minus 2 है. See how I will absorb that. I will absorb that like 2 raised power m जब मैं बाहर ले लूँ, what would be here, यहाँ पे आपका बच जाएगा x raised power m only plus 1 3 5 so on, ये मैंने 2m minus 1 तक मैंने आपका निकाला है. So यहाँ पे क्या बच जाएगा आपका, so यहाँ पे सॉरी एक माइनस साइन आपकी यहाँ पे रह जाएगी. It will be now only 2m, राइट, बिकॉज हम डिनोमिनेटर में 2m डिवाइड कर रहे हैं यहाँ पे, 2m डिवाइड बाई 2m माइनस 1, 2m माइनस 1 एंड m माइनस 1 इज अपना जो यहाँ पे है, देन x रेज्ड पावर m माइनस 2 डिवाइड बाई 2 रेज्ड पावर m मैंने बाहर निकाला, 2 रेज्ड पावर माइनस 2, सो 2 रेज्ड पावर 2 में यहाँ पे लिखूंगा. ओके, सिमिलरली व्हाट आई विल डू इन द नेक्स्ट टर्म, आई विल राइट डाउन दिस एज प्लस सो ऑन. I will now write down the 2m जो मैंने यहाँ पे डिनोमिनेटर में लिखा है वो मैं यहाँ पे अगेन लिखूंगा 2m minus 1, then यहाँ पे आपका 2m minus 2 हो जाएगा again. So this is 2 4 sorry 2 4, that is I have taken it out, so I will be now left with 2m minus 1 and 2m minus 3. यहाँ पे आपका क्या हो जाएगा, m minus 1 into m sorry m minus 2 into m minus 3. Legendre polynomial जो हम ऑलरेडी कर चुके हैं, m minus 2 m minus 3, okay, divide by 2 factorial, divided by 2 factorial. Then I have the 2 raised power 4, m मैंने बाहर निकाला, I have 2 raised power minus 4, that is 2 raised power 4 here, then x raised power m minus 4. Okay, x raised power m minus 4. Now this is I can just write it in a more general form because we already have obtained the Legendre polynomial. I know what the Legendre polynomials has a shape look like. So what I will do, I will write down this as 1 3 so on, 2m minus 1 divided by this 2 4 6 and so on. I will write down this simply this as m factorial. Okay, now 2 raised power m, 2 raised power m, I am going to absorb it like this. I will write down this as first term, I will write x raised power m as such minus m into, I will write down this as 2 मैंने बाहर निकाला 2m minus 1, 2m minus 1 2, so 2 and it will be 2 raised power m minus 1, sorry m plus 1. So I will write down this as simply here m into m minus 1 divided by 2 into 2m minus 1 x raised power this m minus 2, right, because this will be 2 raised power m minus 2, कैसे हो रही है, यहाँ पे ऊपर चला जाएगा 2 minus 2 and this 2 it will be 2 raised power m minus 1. So I will write down this x raised power m minus 2 plus the other term will be now m into m minus 1 into m minus 2 into m minus 3 divided by 2 4, then 2m minus 1 and 2m minus 3, okay, and also x raised power m minus 4, m minus 4 plus similarly I will have the other terms. Now if you'll go to the yesterday's lecture where we have obtained these Legendre polynomials, or the day before yesterday lecture where we find out the solution to the Legendre polynomial, you will see that this is just a Legendre polynomial. So we started from this very equation and from that we extract the coefficients of a Legendre polynomial. So I will write down, so this is just simply a pmx, right, pmx. So I will say that, so we can say we have generated this Legendre polynomials from this very equation. So that means 1 minus 2xh plus h square raised power minus 1 by 2 is equal to summation over some m running from 0 to infinity hm pm of x, where pm of x are the coefficients that I have, the coefficient expansion of this term, and they are called as a Legendre polynomials. Okay, but here it is little I didn't elaborate it, but you have to elaborate on your paper. जो मैंने ये terms मैंने लिखी हैं, I deliberately do it because I want you to work on it. बिकॉज ठीक है, मैंने जानबूझ के ऐसे इसको elaborate नहीं कर रहा हूँ, बिकॉज वी हैव डन a lot of exercise on all this and I want you to do it, like how we have expanded the coefficients. So this is sort of an assignment. यहाँ पे ये जो मैंने यहाँ पे expansion यहाँ पे किया है, ये how ये these. So I find out the coefficient of h raised power m from this term, and this is the coefficient from the in the term this h raised power m from this term. Now the coefficient of h raised power m in this term, this is the last but one term. Similarly, this is the coefficient of h raised power m from what term? H raised power m minus 2 term. So this part जो मैंने यहाँ पे rest of the things will follow, ये वाला जो equation मैंने लिखा है, this is an assignment in the sense you have to elaborate this how actually we are expanding this m minus 1 m minus 2 m minus 1 यहाँ पे 2x raised power, कैसे मैं इसको h raised power m का कोएफिशिएंट ले रहा हूँ इस वाली टर्म को, और इसको मैं कैसे h raised power m का कोएफिशिएंट ले रहा हूँ. For that you need to expand these. For the first case, it's very simple because we have the h raised power m, so simply we will have the 2x raised power m. But for this particular case, you have to expand it, and for h raised power m minus 2, इससे पहले वाली जो टर्म होगी उसके लिए भी आपको ये expand करना है. Then this will follow. This is okay, but once this step I did it deliberately, I did not elaborate it because I want you to do it, and this is take it seriously, right? And the rest of the things are actually associated with the generating functions. Now see, is it okay? Is it okay?
Yes, sir.
Okay, fine. इसको जरा खोल के देख लीजिएगा. You will get it. It's not that tough. But unless and until you will not use this pen and copy and will expand it, it seems tough, but it's not. Okay. Now, if I will ask you one simple problem, we need to show that p1 n of 1 is equal to 1. Okay, we have to find out this, show that this pn of 1 1. I am using this generating function. So what I will do, I will use, since I know that 1 minus 2xh plus h square raised power minus 1 by 2 is equal to summation over this m running from 0 to infinity. I will use now because I have n, so I will use n running from 0 to infinity, uh, h raised power n pn of x, right? So that is actually equal to p0 of x. The first term will be now, sorry, 1 plus h p1 of x plus h square p2 of x, right? Plus so on, h cube, so on and so forth. And the other last term will be simply h and pn of x. Okay. Now what I will do, I will just substitute x is equal to 1 in this equation. X is equal to 1. So what will this equation look like? So it will be simply 1 minus twice h plus h square raised to power minus 1 by 2. This will be equal to when x is equal to 1. So it will be 1 plus this h of p1 of 1, p1 of 1 plus h square p2 of 1 plus h cube p3 of 1 plus so on, right? Okay, now see, can I write down this as 1 minus h square, 1 square plus h square minus twice h, है ना, raised to power minus 1 by 2. Okay, so that means this square and this will cancel out. It will be 1 minus h raised to power minus 1 will be equal to now this thing. What? Okay, this is, I will just keep it as such. This will be equal to 1 plus h p1 of 1 plus h square p2 of 1 plus so on. Okay, now see, I can again expand it by the binomial expansion. This is very simple. अभी जो मैंने कहा n into n minus 1. So it will be 1. This will be implies this will be 1 plus h square plus h cube plus so on. Some other terms, it will be simply equal to h 1 plus h p1 of 1 plus h square p2 of 1 plus some other term. Now I can just equate the coefficient of h on both sides, right? Equating coefficient of h on both sides. What is the coefficient of h on both sides? What is the coefficient? यहाँ पे क्या है कोफिशिएंट ऑफ h क्या है यहाँ पे, p1 of 1 will be equal to now, right,
One.
p1 p1 of 1 will be equal to 1 because coefficient of h here is 1. So यहाँ पे आप इसको लिखिएगा p1 of 1, huh? p1 of 1 is, so this is what we are supposed to prove, right? So we're using the generating function and we can find out that this is equal to this particular, that p1 of 1. Similarly, I can have the hp2 of 1, hp3, p4, p5, and from this very equation. Okay, so this is about the generating function. Now we have to find out the reconciliation and also as a normalization. For the both the cases, we need to know about the generating function. That's why I take this the generating function. मैंने पहले बताया आपको. So let us try to see how many of the reconciliation we will finish. Then okay. Now, so the reconciliations. There are recurrence relations like Bessel functions. We have again here the six reconciliations. I will show you few, rest you can do from those two. The first of the reconciliation is like 2n plus 1 x pn of x x pn of x is equal to n plus 1 p n plus 1 plus n p n minus 1. Yani this is again x p n minus 1 of x. Okay. See how I can do that. Now we know that again the generating function 1 minus 2xh minus plus h square raised to power minus 1 by 2 is equal to summation over n h raised to power n pn of x, right? If I will ask you here differentiate with respect to h, so what you will do, so you will say that it will be minus 1 by 2 into 1 minus 2xh plus h square into this will be minus 2x plus 2h into the differentiation of this thing, right? So here it will be summation over n n into h raised to power n minus 1 into pn of x, pn of x. Is it simple hai na ye? Okay, now what I will do, I will just multiply both sides by generating function 1 minus 2x h plus h square raised to power minus 1 by 2. So when you will multiply it the both sides, so it will be now shabash minus 1 by 2 into 1 minus 2xh plus h square minus 1 by 2 and 1, so it will be plus 1 by 2, sorry minus 1 by 2 oh यहाँ पे ये है ना, so when you will differentiate it, it will be 1 minus 2x raised power minus 3 by 2 n into n minus 1 3 by 2. So 1 minus 2 1 you will multiply it by 1 by 2, it will be x raised power h. So we will multiply both sides by only this factor 1 minus 2xh plus h square. So 1 minus 3 by 2, it will be 1 by 2 minus 1 by 2. Okay, into minus 2x plus 2h minus 2x plus 2h is as such. Again here it will be your summation. Now 1 minus 2xh plus h square into n into h raised to power n minus 1 into pn of x. Just यहाँ पे मैंने इससे multiply किया है. See, now these are actually two terms. I am going to write it like this is minus 2x into this. So minus 2 minus will become plus. It will be simply x uh, x x and this is इस टर्म के बदले में क्या लिखूं? I will write down this is summation over n h raised to power n pn h raised to power इस टर्म के बदले this is 2 and 2 will go minus into minus will become x into h raised to power pn. Okay, minus now this 2 and 2 will go, it will be now h into summation over n h raised to power n p n. तो ऐसा समझिए h raised to power n p n, ये दो टर्म्स पहले मैंने इसके साथ मल्टीप्लाई, बट आई नो दिस टर्म इज इक्वल टू दिस, सो आई कैन राइट डाउन दिस एज सिमिलरली हियर. Now I will write down all the three terms. The first term will be now, it will be now summation over n, इसको मैं लिखूंगा ऐसे. The first term will be n h raised to power n minus 1 p n of x. The second term will be equal to minus 2x h raised to power, जब h से मल्टीप्लाई करूंगा it will be h raised to power n pn of x plus the third term it will be n h raised to power n plus 1 pn of x, right? Pn of x. Okay. Now I will just equate the coefficient of h raised to power n on both sides. So equating the coefficient of h raised to power n, we are equating the coefficient of h raised to power n on both sides such that we are making them equal powers. So like for example, अगर ये वाली term आप यहाँ पे देखोगे, this is summation h raised to power n plus 1 pn, because n plus h into h raised to power n, that is h raised to power n plus 1 pn. So ये equation आप ऐसे ही लिखिएगा as such, खाली यहाँ पे ये change करिएगा. So when I will equate the coefficients, when I'm going to equate the coefficients of h raised to power n on both sides, I am just going to make it h raised to power n. What I will do, I will take n equal to n minus 1, n equal to n minus 1, because then it will be raised to power h raised to power n. So the equating the coefficient of h raised to power n on both sides, equating coefficient of h raised to power n on both sides. ठीक है. So what will be the coefficient of h raised to power n here? It will be x pn, right? X pn of x यहाँ पे. So taking n equal to n minus 1, so it will be minus uh, p n minus 1 pn minus 1 of x. So यहाँ पे n equal to n plus 1, so it will be n plus 1 pn of x. यहाँ पे to make it, यहाँ पे same ही है, so it will be minus 2x pn of x, okay, plus to make it h raised to power n will be equal to n minus 1, so it will be n into n, sorry, it will be now n minus 1 pn minus 1 of x. ठीक है. Okay, so now I can just rearrange the terms here. So you can write down this as this term here, 2xn. So this is again 2xn here, 2xn, 2xn यहाँ पे भी है. This is 2xn. Okay, so on rearranging the terms, I can write down this term. So I will take this to the left hand side. So when I will take this to the left hand side, this will be 2n, 2n plus, this is 2n plus 1, 2n plus 1 into x, this term and this term, because then pn of x, right, will be equal to, now n plus 1 term, it will be n plus 1, this term n plus 1 pn plus 1, यहाँ पे जब ये आपका pn plus 1 हो जाएगा, pn plus 1 of x, this term, and pn minus 1 मेरी दो terms हैं. So I'm going to take it into this side. When you are going to take it this side, n minus 1 plus 1, so it will be simply plus n pn minus 1 of x. So this was the relation we were supposed to prove. Is it okay? ये सिंपल स्टेप्स हैं वहां पे, यहाँ पे खाली एक चीज थोड़ा सा डिफरेंट है. सो इसको, ये तो जेनेटिक फंक्शन है ही है. व्हेन आई एम गोइंग टू डिफरेंशिएट इट, यू विल फाइंड आउट दिस रिलेशन. देन ऑन इक्वेटिंग द कोएफिशिएंट ऑफ दिस बोथ साइड्स टू मेक इट लाइक, यहाँ पे मेरा h रेज पावर n है, यहाँ पे मेरा h रेज पावर n प्लस 1 है. टू मेक इट h रेज पावर n, व्हाट आई डू, आई जस्ट सबस्टिट्यूट n इज इक्वल टू n माइनस 1. दैट्स व्हाई वी आर, जो यहाँ पे है pn माइनस 1 में फिर यहाँ पे लिख रहा हूँ, टू मेक इट, बिकॉज that will make the coefficient to be equal to n minus 1, right? Sorry, h raised power n. Similarly यहाँ पे n minus 1 है, so यहाँ पे मैं put कर रहा हूँ n equal to n plus 1. यहाँ पे h raised power n already है, I do not need to do anything. यहाँ पे n plus 1 है, तो I will just put n equal to n minus 1. ठीक है. उससे क्या होगा, then I will have the same coefficients throughout the h raised power n by just substituting different values for the n. Well, in that case, then when you are comparing the coefficients of h raised power n, we will get these relations. And this is what I called as a recurrence relation. This is the first recurrence relation. Is it okay?
Yes, sir.
थोड़ा ज्यादा ये फास्ट तो नहीं हो रहा है? Am I going
नहीं
too
सर
fast?
ठीक है।
नहीं बाकी सब, am I going too fast?
जी सर, थोड़ा स्लो।